Together, n aardvarks and 12 anteaters eat n squared plus 20n plus 25 ants, and each animal eats the same whole number of ants. So that means we can write down how much they each eat because it's going to be the total number of ants eaten divided by the total number of animals. And we're asked to basically work this out as a number, which doesn't seem like that's going to be easy because we've got just n's everywhere, and this does not factorize involving an n plus 2. But it turns out it will simplify sufficiently so we can work out a unique answer. And there's going to be two ways to do it. Quickest way, if you covered this, is to do some polynomial division. See, this will be covered in year 1 A-level maths, but you may not have covered A-level maths, and you may not have covered this topic even if you have started it. If you're in second year of A-level maths, then yeah, you're ready for it. But we're going to do it another way afterwards. I would say if you have covered it, this is going to be the easiest way though. So I'm not gonna like go into loads of detail on this actually. I've got lots of A-level questions on it elsewhere, whereas I think I talk about it in a bit more detail. But we do n squared divided by n to give us n, and then we multiply back through. It's just like long division with numbers if you've ever covered that. Then we're going to get n squared plus 12n. Now we're going to minus them, just like you would with short division actually. If you're doing 2 into like 715, you would do 2's into 7 going 3, and you get a remainder of 1. That's equivalent to doing 2 times 3, which gives 6, and then minusing them. Okay, that's all we're doing here. It's just a long division version of it. Now, when I minus them, I'm going to get 8n, and then I'm going to bring the 25 down, and then repeat the process. N's into 8n, go 8, multiply back through, I'm going to get 8n plus 96. Minus them, that's going to give minus 71. So what that tells me is that this up here equals n plus 8 minus 71 over n plus 12. Remember, when you get a remainder, like we would over here, we'd get a remainder of 1. That means it's a half. We haven't actually divided that 1 by 2. The answer would be 357 and a half. So that's where this has come from here. Okay, but that is actually the crucial bit to this question because we know that this is going to be a whole number. It has to be. We've got a whole number of ants here. So 71 over n plus 12 must be a whole number, which means n plus 12 must divide into 71. 71 is a prime number, so the only way this could be true is if n plus 12 is equal to 1 or n plus 12 is equal to 71. Now, n plus 12 equaling 1 would give us n is minus 11. We can't have minus 11 aardvarks. That one's out. So it must be the second one, and that is going to give us n is equal to 59. There must have been 59 aardvarks after all, which means the total number of ants that each animal eats would be 59 plus 8. Then we just need to minus the 1 from when n plus 12 is actually equal to 71. That's going to give us 67 minus 1. They must have eaten 66 ants each. All right, here's the way you can do it if you haven't covered polynomial division. So we want to divide by n plus 12. So what we're going to do is kind of not like factorize it fully, but factorize it so we've got an n plus 12 in here. When I say factorize, I mean like take an n plus 12 out. That's what I mean. From as much of the terms as we can. And here's what I'm focusing on, the n squared plus 20n. So I could write this as n plus 8. So that will give me n squared plus 20n, because I'm going to get an 8n and a 12n. But then I've got an extra 96. So I just need to minus that. It's going to be 25 minus 96. And here's my minus 71, like I had before. Actually, I feel like I'm doing that too quickly. So I'm going to get minus 96 plus 25. And all of this is being divided by n plus 12. And then we're in the same position, really. We could write it as n plus 12 times n plus 8 over n plus 12, which becomes n plus 8 minus 71 over n plus 12. Okay, so it's just like a little trick to it, really. I'm going to just give you another example. Let's imagine I had n squared plus 30n, I don't know, plus 14, and I wanted to divide by n plus 10. Right, similar idea. We can force it, so we've got an n plus 10 here. I just need an n plus 20 there. Then I'll get my 30n, and I'll get my n squared. This time I'm going to need to minus 200. Or plus 14 as well, because that's what I was doing. And this would end up being n plus 20, and then minus 186 over n plus 10. And of course, there's loads of options that n could be now to go into 186. 186 has quite a few factors, which we didn't have for 71. That's why this question worked out so uniquely. Anyway, that's just a little bit on how you can do it alternatively. Well done.